All right, this is a mini lesson number chapter 11, which deals with area and arc length and other things like that. And basically, you can read the main points if you wanted to pause and read, but this is what we're going to cover. Here's a perfect example of a question from the chapter. What you want to remember is that the arc length formula is measure the arc over 360 times the circumference 2 pi r. The measure of the arc in this case is 100. The radius in this case is 5. So it's simply just plugging it into the formula. So it's going to be 100 over 360 times 2 pi times 5. And that's going to actually tell you the length of the arc. So when I do this in my calculator, if I want to leave it in terms of pi, I simply just do 100 divided by 360 times 2 times 5. And I get 2.777, which comes out to 25 over 9 pi. If you put it all in there and get a decimal, the answer would be 8.73. All right, and again, we're talking about inches because that's the radius measured. That's the arc length. That's a typical arc length question. Again, measure the arc over 360, and it makes sense. If you're talking about this, you're talking about a fraction of the circumference. And the circumference is 2 pi times 5. The fraction of the whole circumference is 100 over 360. Next question. Look at this for a second. Know your important points. The area of a shaded region is the area of the total minus the unshaded. So the area of the total minus the area of the unshaded, well, the total is a square. So it's the area of a square with side 12, and the unshaded is a circle. So basically I'm finding the area of a square and the area of a circle. The area of the square is 12 squared. The area of the circle is pi radius squared. The radius of this particular circle is actually going to just be 6, because it's going to be half the side. So it's going to be 144 minus 36 pi. You can leave it like this. If you want to get a decimal equivalent, 144 minus 36 pi comes out to 30.9. And that would be your area. And since the sides are inches, you're talking about area, so you're talking about square inches. And you just found, when you did that, you just found the area of all 4 of these little boomerang-looking shapes in the corner. Okay? The area of a regular hexagon. The important thing to remember about this one is that a hexagon is like 6 equilateral triangles, each one having an area of side squared root 3 over 4. So when I break this thing down, it basically breaks down into 6 equilateral triangles. Each one has an area of side squared root 3 over 4, and the side is 4. So it's basically the area of the hexagon is 6 times 4 squared root 3 over 4, which is going to be 6 times 16 root 3 over 4, which is going to be 6 times 4 root 3, which is actually going to give you a total area of 24 root 3. I'm talking about inches, so it's going to be inches squared because we're still talking about area. And that's the area of a regular hexagon. Okay? Angles in regular polygon review. Okay? The sides are n. N is the number of sides. If I have 15 sides, I call it a 15-gon. Otherwise, I call it, by however many sides it is, less than 10. 10 sides decagon, and so on. If there are n sides, there are always n minus 2 triangles, and therefore it's 180 times the number of triangles, which is n minus 2. The sum of the exterior angles is always the same. It's always 360. It doesn't matter what shape you're talking about. Now, if you're talking about a regular polygon, I can find each interior. Well, each interior, you could do one of 2 ways. You could either take 180 minus the exterior if you already know the exterior angle, or you could take 180 times n minus 2 divided by the number of angles, which is n. That's one way to do it. Okay, so these are your 2 ways you can find each interior angle. Each exterior is pretty simple. Okay, 360 divided by the number of sides. And I know this because I know that all the exteriors always add to 360. And if you have n of them, and they are all the same, you will get 360 divided by n for each of them. So if I said, for example, I have 12 sides, that means I have 10 triangles. That means I have 180 times 10 degrees. Sorry, 180 times 10 degrees, which is 1800 degrees, which means the sum of the exterior doesn't change. Doesn't matter what I'm looking at 360. So these are always, you're always going to be able to find these three things. The other, when you have a regular polygon now, if this is a regular dodecagon, which has 12 sides, I can find each interior one of two ways. I could take 1800 divided by 12 and get 150. Or I could have found the exterior first, 360 divided by 12, which is going to be 30. And I could have taken 180 minus 30 and got 150 that way. Either way, if this is a regular dodecagon, it's got interior angles of 150 and an exterior angle of 30. That's one of the things that you need to remember from chapter 7, I believe. Or maybe I'm wrong. Maybe it was chapter 11. I think maybe 11.1 now that I think about it. All right. Area theorems. You also got to know some area formulas. And I'm not going to spend a lot of time. Just pause it if you want to remember these. Pause it if you want to remember these. And if you missed them, you could go back. But you got to know how to find the areas of these shapes. Okay? So I hope that this helps. And I hope that you'll do better on your final now that you watch this. All right. Thanks.